It's asking us for the limit as x approaches 2 from the left-hand side. So the way I like to do it is I trace this thing, all right, I press trace, and then I want to take it to x equals, x approaches 2. So here x equals 0.2, 0.4, 0.6, 1.2. All right, see, I'm approaching x equals 2 right here. And where did my graph go? It just fell down into an abyss, right?
Like,
right, but
when you said about Pac-Man and like that, I think about that so much.
yeah, that's exactly, that's what happens. So as x approaches 2 though from the minus side, the graph falls infinitely down into negative infinity. So here the answer would be negative infinity. Whoops. Okay. So all right. So let's graph that next function. Have you guys seen that next function before?
No.
Okay. So int is the integer function. And the integer function, it's actually kind of cool. Yeah.
For the one before, why isn't it also positive?
Because it was only asking as x approaches 2 from the negative side. So take a look at this. The integer function is one of my favorite functions ever. Like ever. Huh? So we go into math. Second tab is number, and it's the 5th option.
Oh, well, this one looks really cute.
So I'm not going to graph what this says. I'm just going to graph the regular integer function first. So take a look at that. You know what that is? Oh my God, this is so cool. So basically, if you trace it, look, if you trace it, look at the y values. Look at the y values. It's y equals 2, and then y equal, listen, and then y equals 3, and then 4, and then 5, and then 6. So if you notice, the values for y are only integers. 1, 2, 3, 4, 5. You can never have y equals 5.2, y equals 3.1. It's an integer function. It's also called a step function for obvious reasons, right? So for the entirety of like x equals 1 all the way to 2, y equals 1. X equals 2 all the way to 3, y equals 2. X equals 3, it's, oh my God, it's my favorite function. Okay, my gosh, I don't realize how much I miss this function. Okay, we never get a chance to do it anymore. So I think I need to start covering it more in like pre-calc. Okay, so divided by x, right? Let's graph. Okay, so do you see that? Okay, so let's just focus here for a minute. This is a horrible window to look at this graph. All right, because what I want is the values as x approaches 0 from the minus side. I don't need negative 10. I don't need positive 10. So let's go to window, okay? And how about we just go from like negative 1 to 1 on the x-axis, okay? So look, now I really zoomed in there, okay? So where do you think it looks like it's going? Positive infinity. As you approach 0 from the negative side, it's going to positive infinity. Okay? Now, that's what, okay, so you can put plus infinity. You can put just infinity. For the negative infinity, you obviously have to put negative infinity. Now, remember what I was saying yesterday. When your answer is negative infinity or positive infinity, in addition to these infinities, you can also write dne, but can you write just dne for these? No, it has to be both or none, okay? And this is like it's a big thing, okay? It's like, all right, so let's talk about vertical asymptotes. If horizontal asymptotes are defined by y equals a number, so it's x equals a number for the vertical asymptote. Okay? Now, when you have a vertical asymptote, that means as x approaches a number, the graph goes to positive infinity or negative infinity. That's what an asymptote is, right? So if you have your graph, and if there is an asymptote somewhere, the graph has got to follow that vertical asymptote. That means at some point, the graph has to go up vertically, and then it's got to go down vertically. Okay, that's the whole point of an asymptote. All right, so let's take a look at these. So it says find the vertical asymptotes, then describe the behavior. All right, we're going to do vertical asymptotes by hand. Okay, now, here is the thing about vertical asymptotes. Vertical asymptote happens at the point when you simplify the function. That's important. After you've simplified the function, there is a denominator with a variable that does not go away, and it's when that denominator equals 0 that you have an asymptote. So for example, okay, let's factor this. Factor the numerator, factor the denominator. You can't just go in and say, oh, 2x plus 4, I could solve that, and that's where the asymptote is. You have to check first. So when I factor this, I get 2 times x plus 2. Now, did the denominator go away? Were you able to cancel it with anything? No. Okay, that's when it qualifies to have a vertical asymptote. All right? Otherwise, it's a removable discontinuity. All right, so here, because this didn't go away, we take that, set it equal to 0, and x is equal to -2. All right? So that's the asymptote. X equals -2. You've got to be able to find the asymptote by hand. Okay? Yes?
Would it matter if we factor it or didn't factor it and then maybe equals 0?
It would matter if you factor, because sometimes after you factor it, it cancels. It goes away.
Okay.
All right? So let's do the same thing for the other one, and then we'll go on our calculators and look at infinity behavior. Okay, yes, Elliot.
Oh, why did you choose x plus 2 on the bottom then?
Because vertical asymptotes happen when the denominator is set to 0.
And so why didn't you set 2 then also 0?
Well, 2 is a constant. Even if we had, we would have divided both sides by 2 and it would have gone away.
Okay, so then if the top was on the bottom, then there would be asymptotes at 2 places then.
Correct. Correct. Okay, let's factor this. This is 1 minus x, and this is 2x plus 1, x minus 3. All right? Now, did any of the stuff in the denominator cancel out? No. So they both qualify as giving us vertical asymptotes. We take the first one, set it equal to 0, and get x equals -1/2. And the second one gives us x equals 3. Right? Yes?
Yes.
Okay. Now, let's graph that first one, because I think it's a little bit more interesting. Yes?
And then when I did an A, why wouldn't 1,000 asymptote be 0? When you factor out the x, you get that equal to 0. You didn't factor out that.
We didn't factor out an x. We factored out a 2. Uh-huh.
Are we going to need to graph this by hand also?
Sorry?
Are we also going to need to graph this by hand?
No. So, okay. So here we go. We're going to do Zoom 6 again because I know I changed my windows previously. Okay, so take a look at what happened. We know algebraically that it's got to have an asymptote at x equals -2. And look, it does have an asymptote at x equals -2. So let's talk about end behavior. So take a look at this. You see how it says describe the behavior? Let's describe the behavior. So here, the limit of f of x as x approaches 2 from the minus side is what? -∞. Oh, and this is -2, sorry. And the limit of f of x as x approaches -2 from the positive side is what? Positive infinity. Okay? So this is what it talks about when it says describe the behavior. All right, so right now, go ahead and plug in the other function. Everybody, go ahead and take out your calculators. Plug in the second function into your calculator.
With this one, would you need like have like 4 answers? Because you need.
Yeah.
So on the test, though, for this part of the test, did you use a calculator or no?
If it asks you, if you have to look at the graph, it would be on the calculator section. But I can put a function on the non-calculator section and say find the horizontal asymptotes.
Or the calculator just for test behavior?
Yeah, it's if you like have to look at the graph. I'm not requiring you to graph those by hand. Huh?
You mean vertical asymptote?
We're going to talk about horizontal asymptotes too.
We're finding for 2 lines and 2 plus.
Correct. Okay, so when you graph, you'll see that it looks like this. So for the behavior, we have the limit of f of x as x approaches negative a half from the minus side. That's what? Positive infinity. And the limit of f of x as x approaches negative a half from the right-hand side is negative infinity. And then we can do the same thing as x approaches 3 from the, let's be consistent, 3 from the left-hand side, 3 from the right-hand side. All right? So from the left-hand side, it's the same pattern. It goes to positive infinity and then negative infinity. Okay?